have a pretty eventful next couple videos. This video we are going to be firing up the engine and finishing up everything else that remains, which there isn't too much to do. The next video we are going to be doing the first test drive, hopefully in front wheel drive mode. And then the third video we are going to be doing the first test drive in all wheel drive mode when I order the brand new prop shaft from Volvo, as well as all 4 new tires all the way around, because all my tires are mismatched right now. Well, at least the front and rear are mismatched, and that's not gonna work. So let's get into the video and hopefully get this thing fired up by the end of it. So I'm finalizing my forced pinion lubrication system, and you can basically see what I got going on here. So we have 4AN90, and that goes into this little split that splits out to 1/8 NPT, and this is like an extender, and this side was actually 1/8 NPT, but it was perfect because I could drill it out to 10.5 millimeters and then tap it for M12 by 1.5, and I'm able to use this this Bosch coolant. It's basically a liquid sensor. It's basically a coolant sensor, but it can be used for any liquid, and you can see that goes in there real nice and well, and that basically puts that tip pretty close to about here. So hopefully the oil it's seeing is pretty, you know, temperature-wise, pretty accurate, and hopefully it doesn't absorb too much heat from the downpipe. But the downpipe's kind of like way over here, to be honest with you. So hopefully we don't have any heat saturation issues there giving us false readings. And we also have a 30 PSI pressure transducer right here, and that's gonna give us the pressure going into the pinion lubrication system. I suspect it's probably only like half to 1 PSI, maybe if that. But we can use these two things to make sure that our pump is actually working and that we aren't exceeding, I think probably we don't wanna exceed, I guess, 275 degrees Fahrenheit in this case, or at least in the oil. So it'd be good to get an idea what's going on there. And then it kind of also gives us the option to actually hook our pump up to Megasquirt and actually control it closed looped based on pressure. So maybe like higher in the RPMs where there's like a lot of splash lubrication probably going on, or higher vehicle speeds, we might not need as much oil being pumped up here because it might be sneaking through the outer pinion and into here. So it gives us a couple cool options there, but I'm pretty happy with this. I'm gonna finalize it, and you can see we got the hose down here that actually comes out of the bottom of the case, and you can see we got a good amount of clearance to the power steering rack and everything. Plenty of room. So no issues there. And I did test fit the manifold, and it all fits and everything. So we're good with that. I'm gonna wrap that up. Other than that, once this is finalized, I'm gonna fill the oil through here. I'm gonna put 0.75 liters in it. We'll test the lubrication system. And after that is done, I'm just waiting on some new ARP studs. We can get this thing fully bolted on, torqued on. We can put the exhaust manifold on, button up the last couple things back here, like the oil feed, oil drain for the turbo, a couple of the EGT sensors and exhaust gas back pressure sensors. And then that's done. And then up here in the front, we just got to put the intake manifold on, put on some of these PCV pipes, tighten up a couple things, finish up a couple wiring things, and the front's done. And then we're looking good to throw this thing in the chassis. I did some pour 15 here because there were a couple of rust spots starting to pop up, so I sanded all that down. I got that all painted up. Once that dries, we'll be good to go. We got our viscous coupler back there, just waiting for a drive shaft. And other than that, I also deleted the windshield washer reservoir here. Don't need it, never used it, never will. This car doesn't drive that much. Other than that, one step closer. Picked up a new chop saw to do the pie cuts for the, well, cutoff saw, do the pie cuts for the exhaust. Just got a Chicago Electric, it's like $100. I had one before, but it was made for wood, so it had kind of like a plastic deck and it melted it. But the nice thing about this one is it has 0 to 45 each way. So basically we're gonna do 15-degree cuts. Wait for that truck to go by, frickin' asshole. We're gonna do 15-degree cuts, and then basically you do a cut, rotate at 180, do a cut, rotate at 180, do a cut, and that's how you get your pies. The first one, you're gonna leave it flat and then do a cut, and then from there on out, you're gonna have a cut on both sides. I'm not gonna go into too much detail on how to do these pie cuts, but this should work well. So I have this reducer. It's a 3 to 3.5 inch reducer. And basically what I'm gonna do is I'm just gonna cut this right here. And then once that's cut off, this will weld perfectly onto this V-band. As you can see, these are the same outer diameter. But once you cut that down, you can just weld that onto the V-band, no problem. I did that on my old downpipe. You can see I use like that same kind of piece. And then we'll cut it somewhere around here again. Here. I'll probably just measure that. And then we're just gonna replicate this. I don't wanna cut this downpipe up because I might have a use for this exhaust later, but I'm basically just gonna copy this downpipe, which was 15-degree cuts, 2 inches between cuts. And then I think this is like 120 degrees. And then we're basically just gonna go straight and not like 90 back at all. So I'm gonna get this chopped up, start mocking that up and tacking it up to the V-band. And then we can start making our cuts. It's a little dark out. I wanted to get a special angle gauge, a digital angle gauge, so that way I know exactly that I'm rotating at 180 degrees every time. But it's dark out, so I might have to wait to do that tomorrow, but I think I'm gonna do a test cut on this with the new saw. The cut came out pretty square. Cleaned it up a little bit with a grind off wheel and a file. And you can basically see that goes on there perfect, because these both have the same outer diameter. And then you just run your weld all the way around the perimeter, just like here. And then you can see we just gotta lop it off somewhere around like here, but I'm gonna wait on that until we start building some of my pie cuts, because it'll make things a bit easier. You can see. So I'm working on the exhaust again. Figure I'll just give a little overview of basically how the pie cuts work. So basically you want to mark a line on the pipe 180 degrees apart. So you can see I got one here and I got one over here. And usually if you do like this aluminized pipe, usually it has like the roller marks from the, I guess the extrusion or whatever. So you can always use those. Just go over them in gold pen or something. If you want to set your saw to 15 degrees, you can either use 15 or 7.5. 15 is what I'm going to be using. And then basically what you do is you basically push your pipe forward. So you can see I already did a cut here. So after you do a cut, you rotate it 180. So I'd rotate it over 180, and then basically I'd measure this long face and make sure it's 2.4 inches from here to here. So I'd push, pull the pipe out. And that's going to give me 1.94 inches on the long side of the cut, which is what I want in order for a 2-inch radius, centerline radius, 3.5 inch 90. So did a couple bends so far, or cut a couple pieces of pie, and you can see they're coming out pretty nicely. So you can see, they go like that, and you can see how that's going to start forming a 90. Basically, each of these bends are going to be 30 degrees, so I can kind of do whatever I want. But you can also see, you can use that line you made to actually line the cuts up. So you can see that's 60 degrees right there, because there's 15 on each side. So gonna get these tacked up, put the manifold on the head, and then we're gonna get that on, put it in the car. And I just wanna see basically, I'm pretty sure I'm just gonna do like a straight shot, like right here. Like right here is exactly where I wanna shoot it. So that should be perfect. 2-inch centerline radius and right down to the ground. And yeah, just doing a aluminized pipe for now. You can see it's actually exactly the same as my old downpipe. This just has a little bit more cuts in it. I'm doing this quick and dirty because I just need something quick and dirty. So I'm gonna get these tacked up and we'll start mocking things up and should be able to bang this out pretty quick. So you can see I got it all tacked up, and you can basically see, obviously we'll angle this when we torque that flange down, but we're just gonna shoot right through this hole right here. It's gonna be out of the way of the prop shaft, out of the way of the oil drain, all the lubrication system. And you can see how little room I have between the output of the turbine housing and the dump pipe. So I gotta get off there quick, which is why I chose a very small 2-inch centerline radius. And now we just gotta shoot right down here and we're good to go. Probably gonna do something with these fuel lines, maybe build like a little shield here to keep any heat away from them, but let's try and get this rest of this downpipe knocked out. So I got the new dump pipe all mocked up, You can see we just, I think we do a 120 off there. And then we come straight down here. Plenty of room on both sides for engine movement. And obviously I cut this a little bit long. We're probably gonna chop this like up here so we don't have any ground clearance issues. But other than that, I mean, it's in there, it's not in the way of anything, it's not hitting anything. Plenty of room for the oil drain. I'm not even gonna put it in because I know it'll fit. Plenty of room. Just take a look under here, it looks pretty cool. Got a lot going on, but it's all cram-packed in there. Playing around with where I want to put the O2 sensor. Probably gonna put it like right here. Gives me plenty of clearance between the firewall and the turbine housing and all that good stuff. You can see it's kind of hard to hold with one hand, but it clears pretty well. Went ahead and kind of just threw the intake manifold on. I was gonna put everything in the front together, but of course 4 out of the 5 injectors are clogged up from sitting with E85 in them. So it only makes sense to send them out to get cleaned and flow tested, because it's not worth trying to do it myself and possibly not get one fully unclogged and go do the first pull and burn a cylinder up. We don't want any of that. Started labeling some of my sensors. You can see this is crankcase pressure. Over here we got FP for fuel pressure. So I'm starting to put a lot of these transducers in. We have 3 more over here. So we have our pre-IC pressure, our coolant pressure, and obviously we're gonna have our exhaust pressure, which I bought the stainless line and new fittings and all new stainless stuff, and I just gotta run a little pipe over here or something. But I'm gonna do that when I get this manifold more finalized. It's just in there with 2 bolts because we're still missing the studs, the ARP studs for the angle gear. Then of course we got our 2 thermocouples for the exhaust gas temperature and pre-IC temperature, and just a whole bunch of other miscellaneous integrated cop harness. We got our injector harness. Just cleaned so much wiring up and made everything so much neater and tidier and refreshed because it was starting to get brittle and old. I mean, we're close. We're just missing like the studs, and now the injectors are clogged. So I'm not going to be able to start it this weekend, but maybe sometime next week. I don't know. The injector place I use is really close, so usually I get like 2 to 3 day turnaround. I should have sent them out anyway, but I don't know. I've been doing so much other stuff. Got the dump pipe finalized, putting an O2 bung. It's out of the way of everything. It's going to be a turbo blanket here, so I'm not worried about all this wiring, but plenty of clearance everywhere. So this thing shouldn't have any problems. I'm gonna get a couple more tacks on it because it's a little loose, and then probably gonna take it to my guy to get welded. I just don't feel like dealing with it. Entire Pinion lubrication system. You can see we got our 30 psi pressure transducer, we got our Bosch liquid temperature sensor, and we also have the power for the pump. That all runs down here. Probably gonna zip tie it, keep it out of the way of that prop. And the pump actually goes into where the old PTC used to go, the positive temperature coefficient. It was basically just a little heater for the intake pipe so that the PCV hose doesn't freeze. So that's constant 12 with the ignition on, tucked into the same circuit as the injectors and everything. So I think that's gonna work really well, just feeding that thing constant power and monitoring pressure and temperature. Other than that, these 2 sensors are integrated into the big 10 sensor harness that goes all the way over here and pins out to this big Deutsch 12 pin. So this thing's completely full now. It has, I guess, 9 sensors on it. 7 pressure transducers, 1 thermistor, and 2 thermocouples. So a whole bunch of stuff going on with that, but it's all clean, tucked, taped out of the way, and seamlessly integrated into the OEM harness. So I'm pretty happy with how the electronics came out over here. There's also a good amount of room between the steering rack. I really don't suspect that the engine is going to move enough for this to hit. Maybe, but maybe not, because these mounts are just, I've tried moving this engine with these mounts and it is really very solidly mounted. And our downpipe fits no issues. Obviously I put on this little extra V-band for when it gets welded, but so it sticks out a little bit farther than it actually is, but you can see it's way out of the way of everything. So that's good. Shouldn't have any heat issues around this area. So yeah, I'm pretty excited to see what the temperatures and pressures are looking like inside of this lubrication system. Once we get those ARP fasteners, we can fill this thing up with oil. The only reason I don't want to fill it up with oil now is because it's pretty hard to get the angle gear out with the whole lubrication system attached. So what you got to do is you got to take off this top one here and kind of move it all out of the way to pull it out. Kind of a disadvantage, but I mean, this case is built for racing. You know, this isn't built for daily driving or mild street power. This is built for some serious amount of power. So there's compromises you have to make, which obviously I'm okay with. So I'm gonna keep buttoning up the wiring. I gotta label everything else. I gotta label all these connectors and actually tighten these up and whatnot. This one's tight, this one isn't. And I think we're set on the wiring. Here's the new ARP hardware for the angle gear. It is ARP stainless steel, and it actually has a yield and tensile of 170,000 and 180,000 respectively. Yield and tensile strength, which is incredible for a stainless fastener. This stainless fastener is actually pretty much as strong as a class 12.9, so just because it's stainless doesn't mean it's weak. This is a very strong stud, and you can see I got all of them installed pretty much. One thing is they thread in great. You just got to leave it out like 2 or 3 millimeters, like right about like there-ish. You can see so that this nut can fully engage when the angle gear's on. It's just like a little bit too short on this side. It's not a problem because we already have, this would be like 26 millimeters of thread engagement. So like 23 is perfect. It's way better than the frickin' 16 that these puppies had. Like, look at the difference. Let me pull this out and we'll do a quick comparison of the old ARP stud versus the new one. It's hard to find like this kind of stuff from ARP because they don't have like a public catalog, so you got to call them. And depending on who you talk to, they're either really helpful or not helpful at all. So here you can see how much longer the engagement is into the bell housing. It's almost double. So this is ARP 2000 material, obviously way stronger, but that little thread engagement, no way that thing would get pulled right out as soon as you torque that up to 40, 50 pound-feet. So these are going to be perfect. I mean, they're not cheap. It's like 15 bucks a stud and $10 a nut. It was like 100 bucks for all this, but it is the strongest hardware. These holes actually go really deep. They go like, I think 40 millimeters deep, but 25 millimeters of thread engagement is going to be plenty, because really with thread engagement, we're worried about the threads being pulled out. So when you torque them down and preload them, we don't want those threads pulling out. If we torque those down to 50 pound-feet, they probably would have pulled the weak aluminum threads out of these holes. That would have been a big problem. So these are going to work perfect. I'll throw the angle gear on real quick, and then I'm going to show you the quick little setup I made to actually torque these nuts, because you can't really get a standard socket in there. So let's do that real quick and I'll show you that procedure. So what I bought is this special tool to adapt a torque wrench to a box end wrench. It is by Motion Pro 080380. I feel like this is just going to be an awesome tool to have around the shop anyway, because sometimes it's really hard to get a socket and a big torque wrench in a small tight area. So basically what you do is you clamp this on, and if you put it at a 90-degree angle to the wrench like this, then you actually don't have to adjust your torque settings at all, because it's not really extending the moment on the torque wrench. And basically you just hook it up like this and you torque away. So you can see pulling on the torque wrench, and that's turning that. And I think this is set to like 30 pound-feet or something. So it's kind of hard to do this with one hand because there's kind of a lot of play and everything. But let me try. Get this torqued up. So we're getting there. Torquing this to 35 pound-feet, I think, or something. We'll get there eventually. And And torquing. You can't actually use the ratcheting of the torque wrench. You actually have to take the box end off, because if you ratchet it, you'll change the angle in relation to the box end wrench and you won't get a proper torque reading. So you can see this thing's getting torqued up real nice. And hopefully this is the final one. So now you can see the torque wrench is clicking on the box end, so we actually have 35 pound-feet on that nut. So this is a really cool tool, and again, as long as you keep it 90 degrees, you can see it's not perfectly 90 degrees, but as long as you keep it pretty close to 90, your torque is going to be very accurate. If you flip it around and you make it go straight like this, now you're actually extending your wrench this distance from the center here to the center here. So now you're actually getting more leverage on it. So if I were to torque it to say 30 pound-feet with this, I could do the math out and tell you exactly what it would be, but I'd be really torquing it to like 40 or 45. And you'd think you have 30. It's a really easy way to over torque stuff. So remember, if you're using this adapter, use it at 90 and you don't have to make any changes in your torque setting. Of course, sometimes it's hard to get stuff at a 90. Sometimes it's a lot easier to get stuff head on. And if you do have to do it head on, no problem. You can just run out a quick formula and I could basically calculate, just measure from the center here to the center there and calculate how much additional torque I'm actually putting on the thing. But I'm gonna try and do everything at 90 to keep things simple. So that went on real nice. You can see why I had to turn it out like a few threads so that you get full nut engagement on the stud. No need for washers because it's already a flanged nut, and that's just gonna space it out even more, which would be bad. So pretty happy these worked out. This is just an off-the-shelf part for some Porsche, and I'm gonna get the sleeve in. I gotta get one more seal in there, and then we can finally torque this thing to the actual transmission, which is then gonna finally allow us to put on the exhaust manifold and basically finish everything up. That's basically what I've been waiting on. So let's get to it and get this whole rear all finished up. Going to be putting in a brand new OEM sleeve for now. Correct one is 31256008, and then also going to be using Volvo spline grease. This isn't like the sealant grease that like hardens and gets the collar sleeve stuck to the diff. It's just regular old Volvo spline grease. I'm not gluing this thing to the frickin' diff because eventually we're going to replace this with a high strength version from PDV. I joined the group by, paid and everything. They're just finalizing things up. And honestly, this new sleeve, the fit is like incredibly tight on the new OEM sleeve. Like it's kind of hard to get it on sometimes. And you can see it's definitely going to need to be fucking hammered on because, you know, it is a tight fit. So they definitely made improvements on this sleeve. I actually don't think this sleeve will strip at my power levels. I think sleeve failure is more of like a fatigue failure where after, you know, hundreds of thousands of miles of forward and backward backlash, it actually wears down the splines. And then eventually once you get enough load on the thing, like going up a hill or you hit a patch of ice and a bunch of torque goes to the rear, it either just strips out diff side or angle gear side. We're gonna run this for now. I don't think there's gonna be any issues, and hopefully we can get that upgraded sleeve in soon. And we'll put that upgraded sleeve in when we take out the angle gear for like the 500-mile maintenance and check, just to make sure everything's still looking good on the inside, because that's going to be part of the research and development of this billet case. So let's get this lubed up, let's get this put in. There's also an O-ring that goes diff side and angle gear side, and that O-ring basically seals this surface right here and this surface right here so that it can't leak through the splines at all. So let's get that done, and we're going to be one step closer to getting this thing in the car. So I went ahead and I filled the angle gear up with 500 milliliters of fluid. Fun fact, this vent actually won't leak if there's just fluid trying to get past. It actually only leak if there's pressure inside of the case. So there's like a little one-way valve that only allows pressure to get out, and I guess maybe back in if somehow a vacuum develops in here. But that was cool because it means it's really easy to tilt this thing on its side to fill it with fluid. But anyway, what I did, and you can see I cut a little hole down here too for that pipe to make it easier for everything to sit. But I got all the fittings and everything torqued up, and what I did is I hooked this up to my little power pack. You can hear it's chirping away, and I really wanted to get a pressure reading. So I got this down here. I got 5 volts going into my sensor harness. I tested a bunch of my other sensors too, which was kind of cool. And I was able to get a reading. Let me just try and get the right pin. So 0.64 volts, 0 PSI is 0.5 volts. So if you do the math out, you do this a 30 PSI transducer, do 4 divided by 30, since it's 0.5 volts is 0 and 4.5 is 30. If you do that math out, you get about 1.5 PSI, and that's like perfect. That's exactly what I want. So I suspect that the pressure probably isn't going to go up too much, if any at all, when the unit heats up. Because I guess when it heats up, it's going to get a little more viscous. So I guess that's going to make the pressure go up maybe. It should make it go, when it heats up, it should get thinner, so it should go down. I don't know, we'll see. But that's hooked up. Got good pressure. This thing's ticking away. I'm going to let it run a little bit. No leaks. And I'm probably going to fill this with 0.75 liters. So I'm probably going to do, this water bottle was half a liter, so I'm probably going to do another half of this. And that should be plenty of fluid. And again, I'm using full synthetic heavy shockproof red line because we want the best fluid we can get for this. I'm usually a big OEM hardo with fluids and everything, but I'm going to try some of this red line stuff for just the angle gear, and also I put that in the rear diff. And yeah, pretty happy with this so far. I want to test my my sensor here. Ooh, I actually don't have that. Oh, there's a problem. Got a little leak there because I never actually torqued this down. So I'm gonna go ahead and torque that down, and then probably play around with the temperature sensor to make sure it's reading right. So I'm finalizing my forced pinion lubrication system, and you can basically see what I got going on here. So we have 4AN90, and that goes into this little split that splits out to 1/8 NPT, and this is like an extender, and this side was actually 1/8 NPT, but it was perfect because I could drill it out to 10.5 millimeters and then tap it for M12 by 1.5, and I'm able to use this this Bosch coolant. It's basically a liquid sensor. It's basically a coolant sensor, but it can be used for any liquid. And you can see that goes in there real nice and well. And that basically puts that tip pretty close to about here. So hopefully the oil it's seeing is pretty, you know, temperature-wise, pretty accurate. And hopefully it doesn't absorb too much heat from the downpipe. But the downpipe's kind of like way over here, to be honest with you. So hopefully we don't have any heat saturation issues there giving us false readings. And we also have a 30 PSI pressure transducer right here, and that's going to give us the pressure going into the pinion lubrication system. I suspect it's probably only like 0.5 to 1 PSI, maybe if that. But we can use these two things to make sure that our pump is actually working and that we aren't exceeding. I think probably we don't want to exceed, I guess, 275 degrees Fahrenheit in this case, or at least in the oil. So it'd be good to get an idea what's going on there. And then it kind of also gives us the option to actually hook our pump up to Megasquirt and actually control it closed looped based on pressure. So maybe like higher in the RPMs where there's like a lot of splash lubrication probably going on, or higher vehicle speeds, we might not need as much oil being pumped up here because it might be sneaking through the outer pinion and into here. So it gives us a couple cool options there, but I'm pretty happy with this. I'm gonna finalize it, and you can see we got the hose down here that actually comes out of the bottom of the case, and you can see we got a good amount of clearance to the power steering rack and everything. Plenty of room. So no issues there. And I did test fit the manifold, and it all fits and everything. So we're good with that. I'm gonna wrap that up. Other than that, once this is finalized, I'm gonna fill the oil through here. I'm gonna put 0.75 liters in it. We'll test the lubrication system. And after that is done, I'm just waiting on some new ARP studs. We can get this thing fully bolted on, torqued on. We can put the exhaust manifold on, button up the last couple things back here, like the oil feed, oil drain for the turbo, a couple of the EGT sensors and exhaust gas back pressure sensors. And then that's done. And then Up here in the front, we just got to put the intake manifold on, put on some of these PCV pipes, tighten up a couple things, finish up a couple wiring things, and the front's done. And then we're looking good to throw this thing in the chassis. I did some pour 15 here because there were a couple of rust spots starting to pop up, so I sanded all that down. I got that all painted up. Once that dries, we'll be good to go. We got our viscous coupler back there, just waiting for a drive shaft. And other than that, I also deleted the windshield washer reservoir here. Don't need it, never used it, never will. This car doesn't drive that much. Other than that, one step closer. I got my downpipe back from welding. You have to use like a special alloy TIG rod because of the aluminized pipe. It probably would have just been better to take it to someone who could MIG weld it because he said it was a huge pain, but it's temporary and I don't really care. So I'm gonna wipe this thing down, wire brush a little bit, and then hit it with some VHT high temp black paint and get that all done. And I'm also finishing up redoing the screamer pipe in VHT black as well. So I'm gonna get these wire wheeled down, cleaned off, and get them painted. Pretty much got everything in the rear buttoned up. Got the manifold torque, got the oil feed and drain. You can see I got the O2 sensor in, I got my dump pipe, my screamer pipe. I still gotta tuck this wiring up out of the way, but pretty much wrapping everything up down here. Pretty happy with how it all came out. This is a little close. I might move it, I might not. I think it's far enough away that it probably won't melt, but I might just keep rotating this so it points more like over here. Turbo blankets on, so we won't have any heat issues with the angle gear and everything else. You can see our feed line runs over here. Everything's tucked up and out of the way. Nothing is touching the turbine housing or the downpipe. And at this point, I think I'm going to put the subframe in the car. I want to get some of the electronics hooked up. I want to prime the oil system. I want to do all that stuff so that hopefully in the next day when I get my injectors back, we can basically just throw them in and fire this thing up, you know, without any coolant, without any gearbox fluid. We got angle gear fluid, so we're good there. So I'm gonna throw this thing in the body and just put the 4 temporary subframe bolts in and start playing around with some of the electronics and priming the oil system. So I put oil in the engine, I put on the oil cooler, wrapped up a couple more things. I got the ECU hooked up, I got some power and grounds, just kind of testing things out. We got the oil pressure sensor hooked up. I already primed the system. It took a little bit of time, but it was completely dry. But I'm making, let's see, I think I was making 60 PSI on cranking. About 60 PSI. So that's good. Pretty happy about that. That's a really good oil pressure for cranking. And next, I'm gonna hook up my compression gauge. I already got it screwed into this cylinder, and I'm gonna check compression on all the cylinders. This is gonna be like dry and cold, so it should see around like 180, 190 or something. So let's give it a try. And survey says about, just about 190, 195. That's pretty good. And this is just a little jump back too. So this is a high compression engine, so it's gonna take some current to crank this thing over. I'm gonna go ahead and do all the cylinders, and if they're all good, we can, well, we just have to wait for the injectors and we can throw those in, throw the fuel system in, throw some of the ignition in, a couple of the wires, and we can fire this thing up and see if it runs. And then if it runs, we can go into complete assembly mode and just put everything on. So we're getting really close. We had anywhere from like 190 to 200, which is like awesome. That's exactly where it was last year when I did this test with the engine dry and cold. So this engine is, this bottom end is really, really healthy. So looking forward to seeing how these new head bolts are gonna hold up, and hopefully these cracks don't become a problem again. So I'm gonna keep moving along here. So pretty much finalizing some of the wiring. I finished up the external connector for all those sensors, 10 new sensors and everything. Getting the thermocouple amplifier wired in. Tested it all works good. I tested the coil harness, the injector harness. I tested all of the sensors and everything, crank cam. Everything's synced up, everything's all grounded, everything's good to go in Mega Squirt. So today's Friday, injectors are coming tomorrow, which is Saturday. And as soon as they come in, we're gonna throw them in, put the fuel rail on, put the fuel lines in, throw the, we also put new plugs in and gapped them to 30 thousandths of an inch. Put the coils on, wire them all up, and that's pretty much all it needs to start. I just did so much testing, it's all synced. Mega Squirt saying, you know, showing all values for all the sensors. So everything is good to freaking go. We just got to wait for those injectors. I also put new poly bushings here and here, just the IPD ones. So now we have all poly mounts. Every single engine mount is poly. These two top, the side, the front, the rear, or the rear, the front, the bottom transmission mount, everything's poly. So this thing is gonna be mounted. I mean, we could probably try shaking it. Like, it seriously, the whole car is shaking. I used to be able to shake it with the old rubber mounts, but I don't suspect this engine's gonna be moving a lot. But yeah, next clip you're gonna see is hopefully me firing it up. Holy moly, guys, literally one of the most frustrating weeks of this build in a while. Had so much problems getting the injectors cleaned and having a quick turnaround and getting them shipped and everything. And then I got them back, and one of them, freaking cylinder 2, is dead after $150 of cleaning. So I don't know, I somehow got it unstuck. I blew it out. It's in, they're all working now. But oh my God, so annoying. Such an annoying freaking thing. But all the injectors are in. I primed the fuel system. We got fuel pressure. I don't see or smell any leaks. So I think it's time to put the coils on. I also pre-primed the oil system. We got 60 pounds of oil pressure. So I think we can put the coils on. We got our IAC, TPS, crank cam, all the mandatory sensors hooked up, and I think we're gonna be able to fire this thing. So I'm gonna throw this on the tripod and hopefully she fires up. All right, this is gonna be first start. I think I got everything hooked up that I need to fire it up, so I don't know, let's give it a try. I'm feeling pretty confident. That's it, baby. She fired. Let's check it for leaks and let it idle a little bit longer. So yeah, I went under and don't really have any leaks. Don't have any leaks up top. I had a little leak from here because I didn't have this tightened down and I didn't put the new O-ring on. So I put all that on and no more leaking there. I don't see any oil leaks, no fuel leaks. So we're looking pretty good so far. So I'm gonna end this video here. And the next video, we are gonna button up all of this, all of the suspension. We just gotta torque the rear axle nuts. And after that, we can take this thing on a test drive, front wheel drive. I also ordered all new tires. I got Federal 595 RSRRs, which are the same tires I have there. I got 215, 45, 17. So looking really good, guys. So let's get this done and get this thing driving because it's been taking long enough.